Let Sn be the sum of the first n terms of an arithmetic sequence that has a common difference of 2. The quotient S3n over Sn does not depend on n. What is S20? Okay, so the simplest sequence that comes to mind is positive odd integers. And if that were the sequence, then the sum would be n squared, right? Because the average of the terms is n, and there are n terms, so n times n is n squared. Now, if Sn were n squared, let's see what happens. Then S3n over Sn would be 3n squared over n squared, which is 9. And great news, that doesn't depend on n. So 1, 3, 2n minus 1, the set of the sequence of odd positive integers works. And that would give S20 equals 20 squared, which is 400. So the answer is D. Now let's see why that's the only solution. So in general, Sn might be, everything might be shifted by a constant a, right? So it might be 1 plus a, 3 plus a, 2n minus 1 plus a. So then Sn will be not n squared, but all the terms are increased by a, the n terms, so it will be plus na. So let's see what happens to S3n over Sn. So that will be 3n squared, so 9n squared, plus 3n times a, divided by n squared plus n times a. And if we cancel the n terms, we get 9n plus 3a over n plus a. So we can see that this is, for this to be, if not depending on n, a would have to be 0. Otherwise, it's a ratio fraction that depends on n. So if it doesn't depend on n, for example, n, as n gets closer to 0, right, the numerator and denominator will be very small if a is not 0 compared to a. And then the fraction would go to, fraction will be very close to 3a over a, which would be 3. On the other hand, if n gets very big, then the fraction would get closer to 9n over n, because 3a over a terms will be negligible. So it will be approximately 9. So it will change with n if a is not 0. So the only way for this expression not to depend on n is a to be 0. Right, so that's the only solution.